Imagine if I told you that the number 1 is the most recurring main character in the entire world of numbers. Not 2, not 3, always 1. Would you believe me? And before you say no, stick around, because what you're about to hear will completely change how you see numbers. Open any large table of numbers, city populations, stock prices, distances to stars, or follower counts on random social accounts. You'd expect the first digit of these numbers to be spread out evenly, right? But the truth says otherwise. 1 dominates, then 2, then 3, and so on, until 9, which almost never leads. The real shock? This pattern repeats across completely unrelated datasets. It's as if numbers, no matter where they come from, are all humming to the same hidden tune. But that's not the whole story. The story started with something simple. Someone noticed that in old logarithm tables, the pages with numbers beginning with 1 and 2 were way more worn out. Years later, a physicist named Frank Benford decided to check if this odd pattern held up. He gathered tens of thousands of numbers, from rivers, populations, stock prices, you name it, and found the same result. 1 always came first. That observation became Benford's law, transforming from a quirky side note into one of the strangest and most powerful patterns in mathematics. The easiest way to picture this is with a story. Imagine a small island with 1 million people, and the population doubles every year. After 1 year, it's 2 million. After another, 4 million. If you track the numbers in between, most of the time the population starts with a 1. Only later does 2 or 3 show up, and for much shorter stretches, so 1 naturally dominates. That's the intuition, but the deeper explanation is even more elegant. When you look at the logarithms of numbers, their fractional parts are evenly spread out. That balance creates the Benford distribution, and amazingly, the pattern holds no matter what units or scales you use. It's not fragile, it's baked into the way numbers grow. But Benford's law isn't a magic trick for every situation. If your dataset is trapped in a narrow range, like human heights, it won't fit. If humans invent the numbers, like phone numbers, product codes, or those classic $9.99 price tags, the law breaks down. And if the dataset is too small, the effect won't be clear. In other words, not every deviation means fraud, and not every match means everything's fine. Benford's law is a guide, not a judge. Here's where it gets practical. Auditors and forensic accountants use Benford's law like a stethoscope. If the numbers in financial records follow the law, that's a sign of normal organic growth. If they don't, that doesn't prove fraud. But it raises a red flag worth checking. Think of it as a smoke detector. It doesn't prove there's a fire, but it tells you where to look. This is where people get it wrong. You've probably seen viral posts. Look, the numbers don't fit Benford's law, therefore the election is rigged. Nope, that's not how science works. Voting data, for example, is shaped by precinct sizes, aggregation methods, and reporting rules, factors that can easily throw the law off. The same applies to COVID data. Some countries fit the pattern, others didn't, often for institutional or demographic reasons. The point is simple. A deviation is a clue, not a verdict. Nowhere has this been more entertaining than in the world of crypto and NFTs. Some researchers found strange deviations that suggested wash trading or manipulation in certain markets. Others showed that it depends heavily on the asset and the time frame. Sometimes Bitcoin's numbers dance to Benford's tune, sometimes they don't. The lesson? Don't treat the law as a hammer for every nail. Context matters. The best part of Benford's law isn't just its applications, it's the wonder it reveals. We usually think of math as cold and rigid, but here's a simple rule that ties together the messiest, most random-looking numbers, like a hidden melody playing in the background. And it reminds us that statistics isn't just about catching cheats or crunching data, it's about seeing the hidden order in what looks like chaos. So no, Benford's law isn't perfect. It won't convict criminals on its own, and it won't magically explain every number you see. But it is a powerful lens, one that reveals surprising order in places you'd never expect. When the pattern fits, it's a reassurance. When it doesn't, it's a reason to ask questions. Either way, it teaches us something priceless. Numbers may look random, but if you listen closely, they're always telling a story.